So in this video, we're going to talk a little bit about where an angle, where the terminal side of an angle is, how that influences the signs, whether something's positive or negative, of the trig functions. So the first thing we want to do is we kind of want to think about if I had some generic point in the xy plane, right? So let's say here's my point P, and it has some x coordinate and some y coordinate, right? So if you remember what that means, when we say it has some x coordinate, we're talking that this distance here is x. So from here to here is some distance x. And then when we're talking about the y coordinate, we're saying we would go up to this point, right? Some distance y. So we would be talking about that distance here is y, which is the same as that there. So if I draw, right, so if that point was actually where an angle ended, right, so let's say that here was my angle. We've talked about reference triangles, so here's that reference angle. And the idea is that I could kind of rewrite all of my 6 trig functions in terms of x and y. And we call the hypotenuse here, right? We can call it h, or more mathematically, we call it r. And the reason we kind of call it r is because we think about this point as lying on a circle. And so we usually use r for the radius of the circle. So because of that, we can rewrite and say that the sine, so here we have, so we can say that the sine of theta is y over r. Remember, it's opposite over hypotenuse. The cosine of theta is x over r because it's adjacent over hypotenuse. And the tangent of theta is y over x. And then remember the ones that go with it, right? So the cosecant of theta is r over y. The secant of theta is r over x. And the cotangent of theta would be x over y. Okay, so if we think about quadrants and we think about x's and y's, right? So if we think about how we are in a different quadrants. So when we're counting the numbers out here, right, as we're moving out along this axis, we're talking about positive x numbers, right? 1, 2, 3, 4, so forth. So in these first 2 quadrants, right, x is positive and x is positive. And then if we think about the 2 quadrants over this way, quadrants 2 and 3, right, if we're along this axis here, we're talking about that the x's are negative. So x is negative, x is negative. Then we can do a similar thing for y, right? So if we think about y's, if I were going up this way, right, we're talking about y's are positive, y is positive. And if we're going down this way, we're talking about y's being negative. So y negative, y negative. Okay, so if we're going to look at the trig functions. So if we look here, right, if we're talking about the first quadrant, both x and y are positive, and r is this radius, and so we're always going to take the radius to be a positive number. So if x and y are positive, that means this is positive, 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 this is positive. So all of the trig functions in this first quadrant are positive. So all trig functions positive in this quadrant. If we look in the second quadrant here, x is negative, but y is positive. So what that means is the trig functions that would end up being positive, right? If we look, y is positive, so sine's going to be positive. X is negative, so this is going to be negative. X and y is positive, but x is negative, so this is going to be negative. And then these would follow suit, right? Because they're just the same value flipped over. So this is positive, this is positive. This is negative, this is negative. This is negative, this is negative. So the only ones that are positive in the second quadrant is only sine and cosecant. I guess I could just actually write cosecant. So cosecant, positive. And so now if we check the next quadrant, right here, x is negative, y is negative. So this is going to be negative, this is going to be negative. But here I'm going to have a negative over a negative, which would make this positive, right? So same thing, since sine is negative, cosecant is negative. Since cosine is negative, secant's negative. But since tangent's positive, cotangent is going to be positive. So only tangent and cotangent positive. And then finally, in this last quadrant here, right, x is positive, y is negative. So this would be negative, which means this is negative. This would be positive because x is positive, so this is going to be positive. Y is negative, x is positive, so this is going to be negative. These two are going to be negative. So only cosine and secant positive. Okay, so there's a little mnemonic that we use that actually helps us remember what is positive and where, and that is starting in this quadrant, we say all students take calculus. And so the all goes with all trig functions are positive. The S here in students is indicating that the sign is positive, and then once you know the sign is positive, that since remember the sign positive, cosecant is just the sign flipped over, so that's what tells us cosecant is positive. The T is going with the tangent, same deal, and the C is going with the cosine. So it's just a little thing to help us kind of remember what is positive where. Okay, so all that being said, we can now do problems like, for example, determine the quadrant where, okay, so the first one is going to be sine of theta is greater than 0 and secant of theta is greater than 0. And the second one is where the sine of theta is greater than 0 and the tangent of theta is less than 0. Okay, so for this first one, we're looking for sine has to be positive, right? So that right away limits us to the first quadrant and the second quadrant, right? These are the only quadrants where the sine function would be positive because everything's positive here and only the sine and cosecant are positive here. And then the second, the secant is also positive. So if we look, in this quadrant, the secant would be negative, so that means we're stuck here in the first quadrant. So the answer to this one is quadrant 1. The second one, so sine is greater than 0. So again, we're in this first quadrant and the second quadrant. And the second one is the tangent is less than 0. So everything's positive here, so it can't be this quadrant, so it's got to be this one, right? And that makes sense because the tangent is not one of these listed here, so the tangent would be negative, but the sine is positive. So this is quadrant 2. So in those problems, you just kind of have to figure out which quadrant are we in.